Hello everyone and welcome to this video. In this one, we are going to see how you can build your C++ projects using CMake within Visual Studio Code. Hopefully this is going to ease the process for some people to set up compilers, making sure you have one compiler to build your project, or even being able to kick off the process to debug your application within Visual Studio Code. I know some of you are going to be put off by the CMake thing. CMake is really your friend here. It's going to help you in making sure your project is built and you don't have to worry about which commands the compiler use. CMake is going to take care of those things. Let's see how we can do this. Now, first we're going to look at the requirements. To be able to do what we do in this video, you will need an installation of CMake, and it is really easy to install regardless of where you are. We're going to need to go in Visual Studio Code and install a few extensions. And I have to say that Visual Studio Code should also be installed on your system. If you don't have it installed, you can search in Google and see how to install it. It's really easy. But you need the CMake extension for C++ in Visual Studio Code. This is what I say. This is what I should say. And you need the C++ extension in Visual Studio Code. What was I drinking here? Okay, you also need a compiler. In this video, I am going to show you how to use many of the major compilers. I'm going to show GCC, MSVC, and Clang. And hopefully this is going to help many of the students that are taking my C++ 20 masterclass. If you don't know about it, this is a really extensive course that is going to teach you modern C++ from the absolute beginning all the way to very advanced things. We're going to cover C++ 11 all the way to C++ 20. And it's really fun. You can see what other students are saying about the course here. Okay, so let's get started. I am in Visual Studio Code on my Windows machine here. And the first thing I am going to make sure you do is make sure that you have CMake installed. So you're going to run this command, CMake version, and it should spit out a CMake version. If you don't have CMake installed, let's do CMake in our browser, CMake install, and you're going to go to cmake.org. You're going to download it and install it on whatever operating system you are on. Okay, once we are at cmake.org, you can go to download. You see that you can install it on Windows, you can install it on macOS, you can install it on Linux. It's really easy to install. Just follow the instructions for whatever operating system you are on. After you have it installed, this command should spit out whatever version you have installed. Another thing you need is a compiler. Again, I am going to be showing different compilers in this video. You should check that you have a G++ compiler installed. If this is something you want to use, you can do G++ -- version. It's going to spit my version. If you don't have it installed, please check my courses, or even you can check my course on Free Code Camp. I'm going to show you how to install GCC on Windows. We can also check for Clang. We're going to see Clang++, and we're going to see the version spit out here. And you should also make sure that you have Microsoft Visual Studio installed. You see I have Visual Studio 2022 and Visual 2019. Just make sure you have these things installed. Once you have the requirements ready, the other thing you will need to do is to create a folder somewhere on your system. I am just going to grab a folder here and open it in Visual Studio Code. You can see that this is a very empty folder. It doesn't contain anything. And we are going to use this as the sandbox to play with CMake within Visual Studio Code and build C++ 20 projects. So the first thing we need to do is to make sure that we have the extensions installed. You see that I have the C and C++ extension from Microsoft installed. I have the CMake tools extension installed. You can also install this CMake language support for Visual Studio Code to make sure your CMake list.txt files show up better, but this is really not required. But I would recommend installing this if you want to have a good experience with Visual Studio Code. So now I am going to assume that you have the extensions installed. And what we are going to do is to create a CMake project. You do that by coming to View, Command Palette, and typing CMake :quick start. If you do that, you will have an option here. And if you hit it, it's going to tell you to put in the name for your CMake project. Let's say CMake Starter. I think that's a good name. CMake Starter CPP for C++. Once I put in the name, it's going to take that and ask me if I am creating a library project or an executable project. I am creating an executable, so I am going to select that. And CMake is going to generate a starter project for me. You can see that some things are happening behind the scenes, but don't worry about that. Now, you see that in our folder, we have a few things generated. The folder was empty, but suddenly we have a main CPP file. We have a CMake lists.txt file, and we have a build folder. So what is happening here? Well, we told CMake to create a project for us, and what it did, it created the CMake lists.txt file that is going to be wrapping around our C++ project, and it put in a main CPP file, which is going to be the entry point for the C++ application we are writing here. And if you are a C++ developer, you really know this. I don't need to repeat all these things here. Now that this project is created, we need to do a few things. The first thing we need to decide is which compiler we want to use to build this project. Because remember, I have 3 compilers on this system. I can choose to use GCC, I can use Clang, I can use the compiler from Microsoft. And the way you tell CMake which compiler you want to use, in Visual Studio Code, you are going to select a kit. I think I should take out this build folder that was generated for me. I didn't really generate this. This was generated by default. So I am going to remove recursively and remove the build folder. So it's going to go away. And to choose the compiler, you come to View, Command Palette, and you do CMake Select a Kit. And when you do that, you're going to see something magical happen here. These are all the things, all the tool chains, if I can use that term, that CMake can use to build our project. You see, I have Clang, I have GCC 10.2.0, I have GCC 11, I have GCC for x86, x64, I have Visual Studio versions, I have a lot of them installed, and you can see that I have a lot of things, and I have to specify which one of those tool chains I can use to set up a CMake project here. We are going to start with Visual Studio, and I am going to choose Visual Studio Community 2019 Release x86 because I want to build for 32-bit systems. So let's select this. Now our project is going to be set up to build a project that can be built with Microsoft Visual Studio, the compiler from Microsoft, if I can say it like that. So once we have this set up, we're going to configure the project. So let's go to View, Command Palette, and we're going to choose CMake Configure here. You can type this if you want. You can say CMake Configure, and you're going to have this right here. If you select, our project is going to be configured, and what's going to happen, we're going to generate a Visual Studio project that can be built using CMake here. And you see they have generated the build files in our build folder. Let's go there. I think we can go there. We can do sandbox and go in our build folder. If we open this fully, you're going to see that this is really a Visual Studio solution, and we can open it and build it. You can see the solution file here. But we're not going to use Microsoft Visual Studio. We want to use a Visual Studio code. So what we're going to do, we're going to come to View, Command Palette, and we're going to say CMake Build. This is what we're going to do. This is going to build the project, and we're going to wait for it to build the project. And it is going to say, we have built an executable. The name is CMake Starter CPP.exe, and it was generated in this folder here. So what I can do from my terminal, I can go cd build debug. Okay, and if I do starter, let's say CMake starter CPP, if we run it, you're going to see that it's going to say hello world. For example, if we want to make sure that this is actually the binary that is being built, we can say, how are you doing? And we can build again by coming here to Command Palette and build again. So we can say CMake build. But once you have your project configured, you have a bunch of buttons below here. So instead of going to View, Command Palette, and CMake Build, you can just hit the Build button here. And this is going to kick off a new build of the project. And now if we run this again, it's going to say, hello world, how are you doing? You see, this is the thing we're building here. Now we have built in debug mode, but if you want, you can build in release mode. And you do that by specifying a build variant, I think. Let's say variant. Yes, CMake select variant. You can choose either to build in a debug or release mode. For example, we can change to release, and this is going to change to release. If we go back to CMake palette, select variant, and go back to debug, this is going to go back to debug. So we can build the debug versions of our project here. Let's wait for the setting to kick in, and we can build again by hitting the build button. The build is going to go through, and if we run the program, let's say CMake starter, it's going to do whatever it does. Now that we know how to build the project, let's see how you can actually debug this binary using Visual Studio Code and taking the help from CMake. For that, we're going to change this project a little bit. We're going to go in and say stdc out. We're going to put in 3 statements. And what we're going to do, we're going to set a breakpoint on line number 5 here. Now we wanted to debug this program. What we're going to do is to go to View, Command Palette again, and we're going to do CMake debug. So you can say CMake debug, and this is going to say we want to debug our application here. Notice what happens if we choose that. Our application is going to be built, the binary is going to be generated, and it is going to be plugged into the debugger that is associated with the kit that we have selected to build this project with. And this is really magical. You see, we have hit the breakpoint. We can see the locals. We can see the registers. This is really cool. We can see even the registers in our CPU. The EAX register here can catch return values, but we're not talking about assembly here. So let's debug this application. The first thing you should see is that it has already printed 1. You can see that right here. If we step over 2, we should see a 2 printed out. If we step over again, we're going to see a 3 printed out, and we're going to hit the end of our main application. You can see that you can debug the application we built with Visual Studio. But you are saying, Daniel, you can use the compiler from Microsoft because it's Visual Studio Code and we are on Windows and whatever. What if I told you that we can even build with GCC and Clang? Let's do that. For that, we're going to go back to our project and we're going to take out the, let's go up again and take out the build folder. And we are going to generate a new one using the GCC compiler. Let's use GCC. For that, we're going to select a kit. Again, we need to use a new kit. So Command Palette, and we're going to select a kit, and we are going to use GCC 11 here. Let's do that. You can see that now GCC 11 is our compiler. We're going to be building in debug mode. Again, if you want to change the variant, you can either click here, you're going to select that, or you can go to View, Command Palette, and choose Select Variant here. Now we want to configure our project, so let's do View, Command Palette, and Configure. That's what we want. Okay, the build files have been generated, and if you go back to our folder and go in Build, you're going to see that we have generated a Makefile project because we are using GCC. This is the build tool that is used by GCC by default, if I am correct here. Now we can build. We can either click on this build button or do it from Command Palette. We're going to click on the build button here. And you're going to see that it's going to generate a binary called CMake starter, cpp.exe, and it was generated in our build folder. So we can cd into build and say CMake starter. And if we run it, we're going to have 1, 2, 3. Again, we can also debug, and we are going to go through the same steps. We can go to our Command Palette and say debug. I don't know why it's not doing what we told it to do. Let's go to Command Palette and CMake build. Let's do debug again, Command Palette and debug. And I don't know what is happening here. I don't really know what's going on. So what we can do Let's go back to terminal. And we're going to cd up, and we're going to remove the build folder. We're going to generate a new one. I think we are using GCC min-gw32. So let's configure. We're going to command palette, configure this thing. And then we're going to build command palette and build. That's what we want to do. And we're going to do command palette and debug. Okay, looks like now it's working. Something was wrong there, but you see that the binary has been generated. We have hit our breakpoint, and we can step through this thing here. You see that at this point, we can even see our output in the terminal here. If we step over, it's going to say 2. If we step over, it's going to say 3. And we can stop debugging altogether here. And you see, we can build and debug even using the GCC compiler. Let's show you how to do the same with Clang. It is really the same steps, but some of you are going to say, Daniel, please show me how to use Clang. And I really want to cover this. We're going to remove the build folder altogether because we're going to use a new kit. So command palette, select a kit, and we're going to choose the Clang compiler. Now we're going to change to be using Clang. Okay, let's configure. We're going to configure. We are going to be building in debug mode. Now we're going to be building. Let's see the project that was generated. We can go in here and go in build again. And you see that Clang is using the Ninja build system. And this is really cool. Let's close this. And we're going to build our project. We're going to view, command palette, and build. Once the project is built, we can run it. We can either come here to terminal and run it, or we can debug it. So let's do debug, view, command palette, and debug, and see what happens. The binary is going to be generated. It's going to be plugged into the debugger, and we will hit the breakpoint here. You can see the locals, you can see the call stack, you can see all kinds of crazy things. If we step through this, we're going to have a 2. If we step again, we're going to see a 3. And we can stop debugging altogether. And hopefully this really makes it very clear that CMake can ease your process. I have had people report that it's really cumbersome and confusing to set up a development environment using Visual Studio Code on Mac, for example. I believe this process is going to work for Mac. The requirement is really that you have a compiler installed and you are able to call that compiler from the command line. If you can call the compiler from the command line, Visual Studio Code is going to find it, CMake is going to find it and use it to do stuff, and everything is really going to fall in place. All you have to do is come to the command palette and specify whatever it is you want to do. Now, if you are wondering why do we configure before we build, please take a moment to learn a bit about CMake. You're going to thank yourself for that. If you need a detailed tutorial on how to get started with CMake, you can check my YouTube channel. I think I have a playlist for CMake, and it's going to get you started. It's not going to bring you to a very advanced level, but it's really going to get you started and get you doing things like we are doing here. Okay, now that we have reached this point, some of you are going to say, okay, Daniel, but how do I configure this project to use C++20? Well, I'm glad you asked. All you have to do, let's go to my GitHub repository and steal the line that is going to change our lives here. So let's put the line here. We are building an executable using CMake here. And what we want is to tell this executable to be built in C++20 mode. So we do that by saying target compiler features. We need to tell it the target, and the target name is CMake starter CPP. And once we put this here, our project is going to be built in C++20 mode. To test this out, we can take out whatever we have in here and put in code that uses C++20. You see, I am trying to use the three-way comparison operator here, which is a C++20 feature. Let's try to build this project again. View, command palette, and build. And you see that the build is good. We generated our executable. If we go to terminal and cd into build and say CMake starter here, We're going to run it, and you see it is saying 10 is less than 20, which is what we expect from using this three-way comparison operator here. So thanks for watching, guys. I hope you enjoyed the video. If you have any thoughts or suggestions, you can say that in the description below. For now, I am going to stop here, and I will see you next time.